Is that me? Is that my laptop? Awesome. Great. Well, thank you so much for being here despite not having lunch for a few people. My name is Arvind Neelakantan. How many of you are already using Unreal for mobile here? 2 people, 3 people, 4, 5. It's like I killed 5. That's all. How many of you are using Unreal, period? Everyone, mostly. Okay, great. You are in the right place then. All right, so my talk is going to be how you can use Unreal Engine for mobile. So quick agenda, and this is a fairly technical session. I would say sometimes even deeply technical session. So because I think developers are often the ones asking a lot of questions about the feasibility of Unreal Engine on mobile. So this is the agenda that we are going to be talking about. We'll be having Unreal Engine for mobile introduction. I'll be talking on Android-specific workflows, which has quite a bit. And then mobile optimization. I'll be talking about Horde, which is the new CI/CD and pipeline management tool that we have been using for years internally at Epic. And we made it production ready since 5.4. And then about the future of mobile, a question that's always on everyone's mind, which is, hey, does Lumen and Nanite work in Unreal? Well, let's talk about that. There's so much to pack, so I'm just going to go zoom right through it. So introduction, I'm Arvind. Hi. And mobile is very, very important for Unreal Engine. And there is a lot of games that use Unreal Engine to create mobile applications, specifically on the AAA quality side of things. So we have games like the Tower of Fantasy, we have the Oregon Trail, we have Ni no Kuni, and of course Fortnite itself is one of the biggest games in the world, is working on Android mobile and so on. And in our neck of the woods, Raji is quite famous on that front. We have Dream Gaming, who have been making some fantastic games using Unreal Engine for mobile. We have Final Fantasy, we have Blue Protocol. And recently at the Mobile Game Awards in 2024, Unreal Engine won the best game engine platform for mobile, which is quite nice. So let's get into the Android-specific workflows, where I'll be talking about the editor setup, mobile preview, build size reduction, which is a big topic, chunking, and also about the Android Game Developer Extension, or AGDE for short. So if you are new to Unreal Engine and Android, there is a very nice tutorial on the Epic developer community where you can scan that QR code or go to that URL, and that will show you how to set up do the initial setup. So you go in and make sure that you enable your Google Play services, ensure that you have your OBB files all set up, and so on. It's fairly straightforward setup. In fact, with 5.5, there is even a better improved workflow on how you can set up the NDK and SDKs, which is usually the pain point for a lot of developers. For this particular talk, I have been using this example game called Crop Out. If you haven't already checked it out. It's on the Fab marketplace. It's called the Crop Out Sample Project. It is a multi-platform game, optimized really well for mobile, and on the right-hand side, you can see that that's the game I'm playing on my phone. I just took a screen capture of it, and you can download it, and you can kind of go crazy on how they had optimized it. But in this talk, I'll be using this game as an example. One of the first things you want to do when you get an Android project, or when you begin working on an Android deployment, is to preview that game right inside the editor, so that you can see what will that game look like on your Android platform. So you can see that there is an Android button on the top, and you can also see on the bottom there's a preview platform where it says it's Android OpenGL for mobile. But this isn't there by default. So in order to kind of go and see that button, you can go under settings in the editor, and under preview platform, you can select under which platform do you want to preview this game itself. So there's a bunch of options over there. You can also do mobile preview. So you can see that this has a few mobile preview. There's this, you can preview it in Google Pixel, Samsung S8, Samsung S9. But you'll see there's something strange going on over there, right? The shaders are not even compiling. And you can see that the trees are all black, and that's a good way to, in fact, preview to see if your shader that you have written is compatible with mobile development or not. But this, if you want to turn this on, this in fact is an old way of doing it. But if you want to turn it on, you just go under Edit, Editor Preferences, and then under Experimental, which is right there, you can see that there is a allow a Vulkan mobile preview and enable PIE with preview. And once you turn that on, you can then preview a whole number of devices over there. So if you go on Android, you have all of these devices. But you'll notice that these devices are quite old, right? They're not the new latest ones. So a new and experimental way of getting things done is us directly hooking into the Android emulator provided by Android Studio themselves. So we don't have to maintain this anymore. So if you run the emulator, if you go under platforms, you can now deploy directly to the emulator without having to create this kind of experimental things, which is great. And in order to set that up, you just have to get the emulator from, if you already have Android Studio installed, it should be there, but you just need to get the emulator 35.2.7 or anything above it, install that into your Android Studio. In your .android folder under your users, you have to create a new INI file called advancedfeatures.ini file. And once you create that, you can then, inside the INI file, you have to add a couple of lines to just say like, hey, Unreal Editor, just hook in, or rather, Android, hook into Unreal Editor, which is what we're doing. There's in fact a Google thing, Google requirement, where you just say Vulkan on, GL direct memory is on, save that. And once you do that inside Unreal Engine, you can just, it supports all of, ARM64 deployment or x86 64 deployment, and it only supports Vulkan, doesn't support OpenGL because of a restriction from OpenGL themselves. And this is an Android application, an emulator made by Google. So then you can go to Android Studio. Make sure that it's anything, the Android Studio version is above 2022.2.1, which is Flamingo. Just make sure that your emulator is also 35.2.7 and above. Once you have this set up, you can then create your own emulator, which is amazing. So you can create a device. You can select what is your resolution of the device and all of those things. So I'm going to select a Pixel 6 Pro to begin with, but you can then say, what is the system image in it? What is it going to be? Vanilla ice cream? Is it going to be tiramisu? Whatever other versions of Android that you're going to be flashing, and then you give it a name, and once you give it a name, you can finish it, and you can then launch that emulator from Android Studio, and now this emulator is talking to Unreal Engine itself. So you can just preview from Unreal Engine, and this is a really good tool because this emulator is very, very close to the final hardware deployment itself. So a lot of QA testing that we do internally at Epic, say for Fortnite, actually happens on the emulator. So you're able to create multiple emulators, run and deploy your Android game, and you then have your QA people test it on the emulator rather than you having to buy multiple or so many other devices. So this is how you launch. You just go under platforms, and then you just go and deploy the build, or you can just install the APK there directly over there. All right, then the big elephant in the room, which is build size reduction. Someone says, hey, it's like all great, but it's like always huge. Let's talk about how you can reduce the build size and what are the boundaries in which we are working towards. And I want to say right out of the bat, right? If you're making a hyper casual 1 MB game, use some other engine. But if you're making a AAA quality, like really good looking game where you're looking to have it have a longer life for it, because that's how we are seeing games evolve into, Unreal Engine is the best choice. And here is the base that you're working with, right? If I take a base empty shipping build, I'm just create a new project, nothing in there, no starter account, no nothing. And if I create an APK file, it comes to about 75.1 megabytes. That's your baseline. That's how we're working it. And on the device, the memory consumption is going to be 196 megabytes after you unpack the APK file. And if I take a fresh crop out development build, and note the point, development build, which is typically what you'd use for debugging purposes, the size comes to about 218 megabytes. Keep an eye on the little 218 over there. See that number over there? Keep an eye on that, because we'll see how we can reduce that build size starting from that. So 218 for a development build. But you also don't want to ship a development build, you want to ship a shipping build. So if I don't have a development build and I only have a shipping build, which I go and under Android and shipping build, with all the textures, all the texture compression available for Android, it comes to about 169 megabytes. In fact, 170 megabytes on the disk, but that's 169 megabytes is what you would get. But 90%, 90+% of the Android devices don't need all three different texture size, texture compressions. Most of them just are okay with ASTC. Because what happens if you have ASTC, ETC2, and all the other texture compressions is your textures essentially gets packaged 3 times, which you don't want. So just when you're shipping a build, and if you know what your target platform is, you create a separate build just targeting ASTC. And if I do that, you'll notice that my build size also reduced significantly. So from 169 megabytes, it went down to 135 megabytes. Another thing which also reduces build size, which is interesting, is selecting between forward rendering and deferred rendering for your game. And this is a completely artistic choice for the most part, but I just want to highlight something that's interesting saying, this matters. So if I say go under my project settings under rendering, I choose deferred rendering or forward rendering, I can choose what I want. And if I selected forward rendering, the build size reduces by about 3 megabytes. The compression is what I mean. So you can see that if I made crop out not a deferred rendering platform, but made the lighting forward rendering, then it went from 135 megabytes to 132 megabytes, which is interesting. The major other thing that also adds to your build size is your plugins. By default, there is about 147 plugins, out of which many are editor plugins, so you don't really need to disable them. But there are some which are also runtime plugins, which you don't probably want. So if you go and remove some of the plugins that you know that you're not going to be using, that also reduces the size. So I didn't go too aggressive, but from 147, I reduced it to about 106 plugins. Don't, by the way, disable OODL plugins, because that actually helps you with the compression of your textures. But I went down to 106, and then my build size reduced by another 2 megabytes. And I know I'm chipping away over here. I'm like chipping away on build size, but I just want to show you all the things that's available. Then, let's look at what's really contributing to the build size, right? If I open up the OBB file, I'm just extracting the OBB file because it's just like a archive file. And if I open up the OBB file, there is the pack files, which is what contains all the assets inside my game. But how do I look into what assets are contributing to my game? There is a really nice utility under Engine Binaries Win64 called unrealpack.exe file. Now I can use this utility to extract what is inside my game. What are the assets inside my game? So I'm just going there, I'm just going to Unreal Pack, executing Unreal Engine Pack. I'm just pointing it to where my OBB file is, or my pack file is rather. In this case, it's a UCAS file, and I'm just going to say like -extract. And then I have to also then mention a path where this needs to be extracted into. So I'm just saying extracted into this folder. I hit enter, it just takes like a few seconds. There you go, it takes a few seconds, it should extract, and it's extracted. Now let's see what is inside it. So if I go under crop out, I can see that now I'm the extract folder under content. You can see that these are all the things that's contributing to my size. For example, I can go under environment meshes, and you'll see that there is a water plane over there, which you're probably not using. It's just it's there by default because it's there, but you can maybe just go in there and then remove the water plane if you want to, so that also doesn't contribute to your size. There is also another interesting thing where the engine itself, the engine directory also contributes to your build size. So if I go under the engine content folder in the same extracted folder, you'll notice that there is a lot of things over there. You can also, like for example, I go under engine materials, there's substrate over there. In crop out, substrate is not even being used, it's still experimental. So I can go in there and remove substrate also. But I don't want to keep doing it manually, right? There is a way in which you can configure what needs to be excluded from your Android build. And the way to do that is through the default packfile rules.ini file. You can create that INI file in your config folder. So I'm just creating a text document. I'm just going to call it default pack file rules.ini file. Let's name that. And I'm just going to, yes, I do want to rename it. And I'm going to open that up in my favorite text editor. And this is what I'm going to put in. I'll tell you what this means, but essentially, this means that in any time I'm making a build which is targeting a development, shipping, or debug build, and this is only working on the platforms of iOS and Android, and you can add any other platforms, by the way. I can then mention all the files I want to be excluded in the build, including engine files. So I can say here is water plane not needed. So I have some crane cameras that I don't need to be built. So I can then include all of these files, and when I make a build every time, depending on which targets I'm building, all of these files will be excluded from the build, which is great. So all I've done, once I have this, I just have to package the project, and let's see what the build size reduced to. So I went from 133 megabytes, 133 megabytes to 128 megabytes, because I just removed some of the assets I don't need. There's also more places you can reduce asset size by just specifying the maps that you really want to be built, because sometimes during development you have a whole bunch of maps that you're using for testing purposes. Your developers probably created them even without other developers knowing it. So you can then, in the project files or project settings, you can then specify, hey, in my game, I only want these 3 maps to be included. All other maps excluded, which means the dependencies of all the other maps will also be excluded from the build. There is also a fairly, there's a prerequisites installer that is also checked by default, which is typically used when you're making PC builds. You don't need that for Android builds, so you can also uncheck that. And when you do that, that also reduces the build size by about 1 megabyte. So to kind of recount the journey, we went down from 218 megabytes down to 127 megabytes. Most of the 127 megabytes is just your assets. It's just your meshes, your textures, your shaders. So from your baseline project, to make a game like Cropout, which is a full-fledged game, you can make the game in like about 40 megabytes, which is what the 75, 127 minus 75 is what you get. But you can do even more through chunking, because chunking is where you're able to send assets from the cloud so that your users are only going to be getting a thin install of your game. And then all the assets are then pushed, which I'm sure everyone here is familiar with. All you have to do is, to enable chunking, is just go under tools, under project settings, make sure that under packaging you have the use pack file, the IO store, and importantly, have generate chunks turned on. When you have that turned on, you can then, if I go under asset audit, you'll notice that currently there's no chunks. If I refresh, nothing happening, there's no chunks. Just to show you that I'm actually indeed chunking. And now, in order to create chunks where I'm going to separate out assets that doesn't need to be included as part of my build, I'm going to be creating a data asset. The data asset is going to be of type primary asset label. I'm just going to call it under all, I just want all my building assets to be excluded, right? So I'm just going to say like, hey, call it data asset, building asset, give it a chunk ID, apply recursively so that all the assets under the directory are also included in this chunk. I'm going to label my assets. Yes, it is a runtime label, save it. And I can do this for any other asset. So I can then go under say, crops. I also created a data asset over there. And now, if I make a build, I'm just going to Android package project. That will then create new chunks for me, which is outside of the game. So let's take a look at that, right? So if I go under asset audit, I refresh, and now you can see there's 2 chunks, chunk 0, which is my main game, which is my thin client, and then there's chunk 101 and 102. And you can also go into each chunk to then see what does the chunk really have. So I can see the chunk 101 includes all my buildings. So I know that this chunk is going to be excluded from my thin client. But here is an interesting thing. If I go back into my OBB file, which is the packaged file, and I extract it, and I open archive rather, and then I go in there, and you'll notice that this OBB file actually contains all the same chunks, 101, 102, and 0. So what's the point? Because the idea was This has to be excluded from the build, right? If it's already part of the OBB file, we just like nicely separate it out, then what's the point? Which is why you also then need to specify that exclude these chunks Android or Unreal Engine. And to do that, you just have to open up the default engine.ini file and then specify rules saying anything that has under Android runtime settings, you can then specify, create a OBB filter, and we'll say anything that has the name pack chunk 1, and you can, it's just a wildcard. So you can then say like in the wildcard, anything that has this name excluded. And then when you make a build, now I made a build again, and if I now look at the OBB file, you'll notice that the OBB file is already reduced in size, but you'll notice that this only has the thin client, which is pack chunk 0. 101, 102 is excluded from the build, which means your build size is reduced significantly. And it's not, the other chunks didn't go away anywhere. If you go under saved, staged builds, intermediate, and to your project name, under content pack files, this is where all of your pack files live. This is outside the game. And then you can, so you can see that you can reduce the game size from 127, and I reduce this to about 120 megabytes, but it's really up to you. You can then say, I just have one, like a very thin client, and then all the assets are then loaded from the cloud after the user has launched the game. And if you want to know more about how you can host these chunks from on your cloud, on your server, check out this URL. So you can take these chunk files, host it on your cloud, and then load it on your game. So there's also a URL over there, which is tinyurl.com/manifestue. Will just take you to this Epic Developer Community portal. All right. How many of you have seen this? You launch the game, it crashes. It's a lie. Come on. How many people have seen this? Where you launch the game, it crashes. Yes, correct. And really, there's some people who are not raising their hand. I think their boss is next to them or something. I don't know. But this happens all the time. And typically, as Android developers, your instinct would be, I'm going to open up my Logcat. I'm going to see what's causing the crash, right? Right? Right. But there is a nicer way to do it. There is Android game development extension, which is provided by Android themselves. This is an extension to the Visual Studio itself. So you just go to like search for Android game development extension for Visual Studio, just install it and make sure that your project, this by the way works only if you're working on a C++ project, doesn't work on blueprints. But if you're creating a C++ project, create a solution file. And in your solution file, make sure that after you created a solution file, you're packaging the project, because Visual Studio cannot package APK files. It can only help you debug C++ code. So I'm packaging the project. And in my Visual Studio, I'm setting my build to be a debug build or a development build, and I'm pointing to my project that I want to be building from Visual Studio after I package it. And I have my Samsung phone connected to my device. So I'm just going to hit play. Now let's see, if you're using Android 14 or less, and by the way, it's fixed on the latest version of Android 14 by Google, you might get the SIGBus error where it's unable to connect to the Android game development extension. You just have to make sure that you go under debugging and under LLDB post-attach commands, you're adding this command so that it overrides that error. This is what that command is, if someone wants to take a picture. But if you do that, then it's only like a one-off thing, right? But if you do that on any other version of Android, this is the behavior. So you launch the game attaches itself to the Visual Studio game extension through its game thread, and if there is a crash, let's see if there is a crash, I launch the game, and there should be a crash. There you go, it's a crash. It crashed, and it crashed on the line in which I had an error. And someone had called a class called crash actor. I don't know who did it, but that's what crashed the game. So we know, and this is also great for debugging purposes. So if you're using C++ code, then you can use the Android game development extension to then debug line by line in your own code rather than deploying and then testing what's happening. If you're using a C++ project again, you can also have faster iteration times on your Android project if you turn on your don't bundle libraries into APK as true. You can set that up either in the project settings, where you can just have a checkbox, or you can go to your default engine.ini file and set that as true, which means if you're a developer, programmer, every time you're making an APK file, it won't bundle the assets. It will only compile C++ code and push it, which means it's super fast. Your development iteration time is ridiculously fast. It's great. All right, so that's how you would debug Android projects. Let's look at optimizations. Some typical optimizations that you would be looking at: meshes, textures, CVARs, HLODs, and PSO caching. So Nanoid isn't supported on mobile today, right? But if you want your assets to be, because by default, if you have a Nanoid asset, we'll just go back to the fallback mesh, which could be heavy. So we want to optimize the meshes, but you can't optimize meshes and create smaller versions for every project, especially if you every asset, especially if you have a big project. So we help you do that. So if you open up the mesh window or the editor, you can go under. You have to create LODs, which you can auto-generate. And if you go under the minimum LOD settings, over there, you have a plus button next to it. And that plus button can override a particular LOD when you are developing for, say, mobile. So I can say when I'm developing for mobile, when I'm packaging for mobile rather, default back to LOD 2. But when I'm making the same game when I'm packaging the same game on PC, then use Nanoid, it's okay. But mobile, go back to LOD 2. In fact, that will also reduce your build size. So if you have like thousands of assets, doing that would be painful. So you can just do it for one asset. You can copy that LOD settings, select all other assets, and you can paste that LOD setting. So all the meshes in your game can then default back to your lower LOD when you are deploying for mobile, which is great. Now let's look at texture optimization. This texture, for example, is a 2K texture. And on mobile, especially if it's not a hero asset, I don't care if it's a 2K texture. What is important when you're creating a texture is make sure that you have a texture group selected for those textures. And in this case, I selected the texture group as world, right there. Oh, you can barely see this. That's terrible. I can see it so clearly here. But texture group is set as world. What that helps do is if I go to my device profiles, in my device profile, I can specify overrides of all the platforms in which I want to specify overrides. So in this case, I have a whole bunch of devices supported by Unreal Engine, including Android. And I can go to the parent Android setting, and in there, under the texture LOD settings, which is right there, believe me, that's texture LOD settings, there is world, that's world, and I can then say, every time I'm packaging the game with this particular texture group for Android, don't make it the default texture size, make it a 1K texture or a 512 texture. So what this does is, even though you might have a 4K texture, 8K texture in your game and your artist has added it inside your game, you can go to the platform override or device profiles and then say, when I'm packaging this game for Android, reduce the texture size automatically for me, which means that will also reduce your build size. While we are in that place, you can also add console variables or overrides to the console variables, where I can then say like, hey, if I'm developing for mobile, I don't want this rendering, some kind of rendering. I don't want like physics enabled for some reason. So in crop out, the little characters have a hat that bobs up and down, which uses physics. Maybe on mobile, I don't really care about it. So I can disable physics through the console variables also. Now let's look at shaders. In shaders, one of the first things you want to do is look at the platform stats. And you'll notice by default there is the DirectX SM6 and DirectX Mobile. Android isn't showing up, so you can go under settings, which is right there, and enable Android. But you'll notice that there is a warning that shows up saying it is unable to look at the instructions count, because this isn't supported at this point of time. And that's only because you have to just enable the Mali offline compiler, and you have to download the Mali offline compiler because that's empty at this point of time. So just go to the ARM website, get the Mali offline compiler exe file, go back to the editor, and then set that path to where that mali.exe file is. And that's it. And then once you do that, then you can, then you'll be able to see the shader count. So if I have that set up, if I go back to my material, you'll now notice that that warning has gone, and I can see the shader instruction count for that particular shader. There is also a cool feature that we use quite often on Fortnite, which is the feature level switch, which is right there. And that's a node that's been around for about since 4.25, where you can then specify, if I am building the game for, let's say, SM6, then use these shader nodes. But if I'm building it for, say, ES2, then use these nodes. So you can have just same one shader, but the shader during compile time will pick and choose which nodes to be using, which is also useful when you're doing cross-platform development. Another thing which you'll often face is this problem. How many of you might have seen it? Like when you're moving around your game, it suddenly like stutters, right? Quite often, everyone sees it. And we know that one of the reasons, there could be like a million reasons for it, but one of the reasons why this happens is because of PSO caching or caching, shader caching. Because the shaders are compiling in real time as you are moving, and then so there's a stutter. So we have enabled a runtime PSO pre-caching by default. So in theory, you shouldn't see this anymore, because it's enabled by default. It's already available with Android Vulkan and OpenGL in 5.4. With iOS Metal 5.5, it will be there. And there's a lot of fixes for pre-computed lighting and optimizations in 5.5. And with 5.5, it's enabled by default on all platforms. Oops. Previously, we had this method called PSO gathering. And this is a method where your testers or your developers will have to go into every nook and corner of the game, gather the caches, which are the shaders that has to be compiled, gather those caches, and that cache has to be then bundled as part of your game itself, which is a very painful process to do. Has anyone done that, PSO gathering? No one. Great, you had a good life then. But if you have a pretty big game, then this is quite painful. Which is why PSO pre-caching helps quite a bit, because a few frames before you're able to hit that, PSO pre-caching comes in. It's able to then pre-cache those the shaders, and it's one of the biggest advantages. When you're doing PSO gathering, it also adds to your build size, because you're bundling all your caches along with your build. But PSO pre-caching, your build size doesn't get any bigger. And there are certain fallback strategies that you could also enable. You can say, if the shader for some reason doesn't get compiled during runtime, you can go back to a fallback texture, or you can also just not render that mesh at all. You can also just ignore that mesh if it's not going to be a hero asset. So between PSO gathering and PSO pre-caching, you can kind of strike a balance. It's not like PSO gathering is gone, but you can strike a balance, and you can say, like, all my assets that's far behind, maybe use PSO caching enabled by default, but maybe some hero assets I am going to be doing some PSO gathering and bundle it along with the game. Okay, last part for the most part, which is Horde. How many of you here use any kind of CI/CD pipeline and any kind of version control system? That's all? I'd be very surprised. There should be a lot more people using some kind of CI/CD pipeline, Jenkins, Bamboo, whatever you're using. How many of you use GitHub? Yeah, that's that exactly. Perforce. 3 people. Okay. So Horde is a tool that we have been using for a very long time within Epic to make our own builds, including Fortnite. But now we have given out, and it's production ready since Unreal Engine 5.4, where you can have your own CI/CD pipeline that we have been using for ages, and you can set it up for your own games. If you want to know more about how to set it up, check out this QR code, because that has clear instructions on how to set it up. But what is very interesting over here, and you cannot see it really, is there is the remote execution, which is the first one, and then there is the build automation, which is the second one, which includes your CI/CD pipeline. And finally, you also have the mobile device management as part of your Horde development itself. What does these three do? So remote execution is where you're able to like compile C++ code onto another machine. Hello. So you can have a cloud machine or just another PC that you might have lying around in an office. CI/CD pipeline is where it can take shared resources, including your own PC when it has an idle time. Let's say you're gone home, and you can still use your CPU for building your game, which is what the build automation does. And finally, the mobile device management is where your QA testers will automatically get the deployed version of your APK every time the build is done. So you don't have to install it manually. All the devices, including physical and emulated devices, can have the APK files deployed automatically after the build is done, which is amazing. So here is how you would do it. So if this is the Horde interface, by the way. You have all my Android devices over there. I can check out a device. So I can say, I'm a QA tester. I'm going to check out this device so no one else uses that device. So people know that I'm testing it. And then I can then say, hey, and then you'll get a message saying like, hey, this device has been checked out. So it's checked out until this time. So someone is testing that game. And when it's checked out, every time you're making a new build, that device will not get that build, because it's being tested upon. You can also add multiple mobile devices. So if I go under server pools, I can then say like, here is all my remote devices that I have over here. I can specify a new device. So I'm just calling it like say dummy device. And I can say like this is going to be part of my remote UE5 pool. You can create your own pools, by the way, but it's going to be a remote UE5 pool. You can specify what the address is. Addresses and the IP address of all those devices. And when I'm making a build, I can say it's going to be an Android build, and in the device manager URL, that is my URL where all my devices are connected to, and the device pool is going to be my remote UE5 device pool. And when I click create, when the build gets built, APK gets built, it will then deploy all the APKs to non-checked out mobile devices which were part of the remote UE5 list. Amazing. I love this. By the way, all of this is just not like magic. It's just using build graph, which has been around for a while within Unreal Engine, which allows you to automate a lot of these tasks. So you can check out this link, and that's how you learn how to use build graphs. Now here is an example, right? Like in my open world system, I added a HLOD build, which is not a tab that's available by default. I added my own tab so that I can create a separate build only for HLODs. And in order to do that, typically if you look at how to create HLODs manually, you can go to that URL. But there is a command line tool that you would use in order to build the HLODs, which you can see right there. That's the commandlet. You can then run this command through the build graph, which is editing an XML file. So if I just go into this JSON file, which is the Horde JSON file, and I am adding a new tab. If I just go down, I'm just adding a new tab over there, and I'm just calling it that it should be using the HLOD build. Now this tab title is what you would see in Horde. And then this template is what is very important. Template is essentially your build graph. So I'm just going to go under the HLOD build, which if I scroll down into the same JSON file, it's going to have that some configuration for the build graph. This is what the build graph looks like. No, you can't see anything at all, but it's just, you remember the commandlet I showed you for HLODs? You can essentially, you're defining the same thing over here, but I'm adding other things like once the HLOD is built, commit it to Perforce. And you can make it do a whole bunch of things, doesn't have to do only one thing. So once this is done, this is all the parameters in the build graph that I can input from Horde. So I can then say, here is the parameters, here is the map that I want to build, should it commit to Perforce or not? You can do all of those things. So here is the experience, right? I go under HLODs, I'm going in there, and this is my build graph, and I'm just saying like commit to HLODs or not, and then I build, it will automatically build the HLOD, and it needs to be committed to Perforce, it can do that too. Awesome. So that's Horde, And Horde, we have been using it for ages within Epic, so it's been battle tested like crazy. And I've been using Horde quite a bit because I have 2 PCs at home. Even with 2 PCs, it's super helpful because I can just offload a lot of my C++ compilation, build compiling, testing, deployment, all of that to my other PC, and let this PC do my development work. And when I switch off or when I go home, I can keep both those CPUs on and have Horde use both those resources as a shared resource whenever I'm making like large builds. So let's look into the future. So first off, mobile rendering. PSO pre-caching is now enabled, which I already talked about. There's also a lot of improvements when it comes to screen space reflection. Mobile forward support is now available for lit decals, rectangular lights, capsule, and point light shadows. There is also an experimental desktop deferred renderer with Lumen available for mobile, but this only works on high-end devices. Doesn't work if you have Lumen working on low-end device, it won't work. We also have the screen space reflection, decal improvements on Switch, which is also like a mobile device, performance optimizations, light HDR mode to replace your LDR mode for mobile VR devices. So beyond 5.5, we are working very much on Nanite on mobile GPUs. We have already seen some very interesting and positive results on higher-end devices, especially on iOS devices. So that's pretty nice. And we also have mobile forward render improvements for VR. On the memory side, the memory insight support on iOS and Android is getting a rehaul or getting a nice UX overhaul, which will help us diagnose specific Android and iOS memory leaks and memory issues. So you're able to diagnose that a lot better. There are lots of memory savings as such that we have done behind the scenes when you're deploying for mobile. And for the future, you must have noticed this already, right? I chose a lot of editor preferences and project settings and INI files and all of those things. That's a lot of settings. We are very aware of it. So in the future, especially with 5.6, we are consolidating a lot of mobile-specific settings into the editor so that you don't have to do all of these things. But now you kind of are aware of what's going on. But we're making like discoverability of properties relevant to mobile specifically to be a lot more better. There are also better tools to analyze asset cost per platform, which I already sort of talked about. And also mobile preview, which I also just showed you how to do it. So we have the mobile preview is production ready. So connecting to your Android emulator is done. We also have a half-16 emulation done, which means that you can have multiple devices running different kind of shaders, kind of render accurately what that would look on the device. We're also having on-device profile capture on the emulator and on your device. And there's also just general improvements in on-device iteration paths, especially when you're making very, very large games, so your iteration time will be a lot faster. In the future, when it comes to mobile preview, currently you saw I was using one emulator, right? But we are also going to be supporting multiple emulators that you can run on your device at the same time, which is great. So you can just click deploy, all 6 emulators will have the Unreal Engine, which each having its own platform and all running simultaneously. And we'll continue on-device iteration paths to make it a lot faster. And we will also have a revamp on the Unreal Remote app, which is usually just streaming the content on your device. So that's pretty much it. I am super on time. Yeah, if you have more questions, I'll be happy to answer them. In fact, I have a session scheduled right now, in fact, at the booth, where I can answer any kind of Unreal Engine for mobile questions that you might have. But I hope that with this talk, I kind of convinced you to take up Unreal Engine for mobile because we are very, very serious about mobile, or at the very least, kind of just take a look at it, like, experiment with it to see if all of what I was saying was true. So with that, thank you so much. And I am Arvind Neelakantan, and I'm here to answer questions for you. Thank you.